students, Mr. Mester coming at you with your 1.1 homework video. 1.1, we focused our attention on our warm-up, kind of talking about line segments, but then reviewing algebra. Most of the lesson was all about constructions, which is going to be a big part of your Unit 1 project. Your homework is going to focus more on the algebra stuff. So we got to make sure we remember our stuff from Algebra 1 coming into geometry, keep our algebra skills on the up and up while we're in geometry. So you'll see lots of solving equations with this, with some context of what if we have this situation with these kind of shapes. So we can see we want to interpret the problem, translate the information, answer the questions. So we can see line segment MP. We have MN is equal to 3x, NP is equal to 2x, and MP is equal to 20. I'm just going to go ahead and start by having my picture labeled. Sometimes you won't be given the picture, and we would suggest you draw it. MP, so from here all the way over here, is going to be 20. And from there, first, we could then write equations. Okay, so MN, this line segment, is equal to 3x. NP, this line segment, is equal to 2x. And MP is equal to 20, this entire line segment. It's very important to write down your information, not just go straight to the answers. We know a lot of you can go straight to the answers. Substitute known values. Well, it's like we know that from here, we could write one large equation connecting all three of them with Mn plus Np equals Mp. And we can go from there. Oh yeah, that's kind of what we wanted you to do there. So pause. Like sometimes it's like, what are they actually asking you? We want Mn plus Np equal to Mp. That is kind of what we are looking for here, as well as these three things here. And then for part B, what we want you to do is replace, substitute Mn equals 3x, Np equals 2x, Mp equals 20. And from there, we can use our equation to solve. Same side combine. Remember, with equations, things need to stay balanced. It's either you're doing the same thing to both sides of the equation, or if you can combine things on one side, that's fine. What we're not doing, which is a big mistake students make, is trying to do that. If you do that, you break the balancing of the equation. We are subtracting 4x from one side of the equation. We're doing nothing to the other side. So just remember, I like to say same side combine. And then if you're working on both sides, keep it balanced. So same side, we're just combining. And then we can either just do this next step in our head to know that x is 4, or keep things balanced, divide both sides by 5, and here we go, x is 4. And from there we have Mn equals 3 times 4, which is 12. We have Np equals 2 times 4, which is 8. We have Mp already equals 20, and we're good. Justify your answer. This is kind of like the justification, just having the statements written out and then using the substitution. Okay, we have B is a point on the segment AC. We got AB, we got BC. If AC is equal to 14, B, the midpoint of segment AC. Well, again, we will know that AB equals 2x plus 3. We know that BC equals x minus 3. We know that AB plus BC equals 14, or segment AC. So I can set up 2x plus 3 plus x minus 3 equals 14. We can then, on the same side, combine our like terms to get 3x. 3 minus 3 is 0. Our numbers are gone, and we get x equals 14 thirds after dividing both sides by 3. Is B the midpoint of the segment? Well, if B is the midpoint of the segment, we really didn't even need this. The question is like, can 2x plus 3 ever equal x minus 3? And that would be if x is equal to -6. This is one way to check without using 14. Now we have an equation. We got two sides. We can't combine our x's to make 3x. We'll have to remove an x from one side so they remain on the other side. We'll have to remove the 3's from one side so that they remain on the other side. You could remove the 3's from this side, but then we'd have x plus 6 equals 0. Here we'd have x equals -6. That doesn't seem right. We'll talk about that later. Could we have a line segment that's negative? So that's one way to say no. 2x plus 3 only equals x minus 3 if x is equal to -6, which causes a problem we'll talk about. We can double check if we have 14 thirds and plugging it into both, and we can just say no. We know that 14 thirds times 2 plus 3 is not going to be the same as 14 thirds minus 3. Okay, now we can go and show our work from here. It's like, if AB equals BC, then B would be the midpoint, which we know is not true because if that was the case, then x would have to equal -6. Does that make sense? No. Why not? We don't like negative lengths for line segments. Okay, so that's kind of like a good intro of like algebra within the context of geometry, which a lot of this year will be. It will be like solving equations, but with pictures essentially. So good intro to that. Before we kind of continue with that, we have to make sure that our algebra skills are strong so that we can be successful for the rest of the year when we see algebra in pictures. So we are going to solve these equations and make sure that we are on the up and up with our algebra skills. So remember, same side combine. On both sides of the equation, just keep things balanced. Do onto one side as you would do on the other. We like to combine our like terms, but depending on the situation, we have a's on both sides of the equation. We need to remove them from one side so that they remain on the other side. Same with numbers. We like to remove them from one side so that they remain on the other side. Again, we can't just combine the 4 and the 54. Many of you are probably doing fine on this. Some of you might not be, and that's okay. We are reviewing and it's okay if you're struggling. If you're struggling, ask for help. Sometimes we need to unpack what I call packages. Like when I see quantity 3x plus 5, I think about having 3 boxes of 3x plus 5. If you have 3 boxes of 3x plus 5, empty out the packages. What do you have? You have a total of 9x plus 15. This is distribution. This is just emptying the boxes so that you know what you have in total. Good start. Here, I got 12x, I got 10, and I got -3x on one side of the equation. This is the idea of same side combine. 12x's minus 3x's, well, I have 9x's on that side. Now here comes an interesting situation. If I remove the 9x's from that side, and I remove the 9x's from that side, all of a sudden our x's are gone and we get this statement 15 equals 12. This is not true. This can't happen. What does this mean? This means that no matter what x I choose, no matter what number I choose, any number you want to try, it won't work. There is going to be no solution for x. We got a negative number here. It's good to practice with negative numbers. Let's combine our x's, remove them from one side so that they remain on the other. We have 14. We will divide by the -7 to remove the -7 so that we reveal x's value. And there it is. That's really what solving an equation is. It's just like revealing the hidden value by kind of undoing what is being done to this unknown. So that's fine. Here, on the same side of the equation, on one side of the table, you got 3x and a minus x. Don't add x to both of these. Instead, just combine them. On the other side, we have this. Now be careful. You might be like, oh, negative 2x, 2x, these are going to go away. But I want to remove the minus 2x's by adding 2x. I have 4x. Now let's get the numbers all one side. You can do this all by yourself. Do we need to show work? We want you to show work at the early stages of this class, as we are not sure exactly how you are getting your solutions. We want you to show work so that when things get more complicated later on, we can figure out the mistakes that you're making. So please show your work in this class as much as possible. Cool. We got some fractions. You could get your calculator out, but I'd like you guys to all try to do it without. I have a half of an x minus 5 in a bag. I have 6 of those bags. If I unpack all 6 of the bags, all the half of the x's, 6 of the half x's gives us 3 x's. 6 of the minus 5s gives me a minus 30. Sometimes, and I will tell my students, I like to change subtraction and to add the opposite. It will very much help us, especially in this situation, if we make sure we understand that we have a negative 0.25 so that we distribute the negative. I'll show you the mistake that many students make. We have negative a quarter of 12, which is going to be negative 3. We have negative a quarter of negative 4. Negative times negative is positives. I like to say, I'm not smart. What does that mean? Sometimes I'm smart. A quarter of 4 is just 1. All right, good. We have 3x minus 30. We have 2x minus 3, or plus a negative 3. This could be plus a negative 30. I like that so that I can make sure I'm working correctly with my signs. I'm going to add 30 so that they go to the other side, and I get x equals 27. I would love to go back and check. This would be a good time for a calculator. Plugging in 27 into both sides of the equation, making sure that everything works out. We can do. Cool. I might just do that real quick. Yeah, just to show you. Let's just go into Google. Yeah, let's try that. Ready? Let's do 6 times 0.5 times 27. I'm going to substitute it in with parentheses, minus 5. That equals 51. Okay, cool. And let's do 27 minus a quarter of 12 minus 4 times 27. and that's equal to 51. Okay, we got both sides are balanced. We are good. If you have a calculator, that's a good thing to check all your equations with a calculator. We talked about earlier, sometimes, just statements aren't true, which means X can't have a value. If we ever end up with a false statement and no X's, then like X can't be anything. There's no solution. There's no hidden value for X. Let's unpack this box of X plus 2. I have 3X plus 6 after unpacking it. Well, what happens here, after removing the X's, they get removed from both sides. I have this true statement. What does this mean? No matter what I pick for X, it will work. The left side will be balanced with the right side. X can be anything. We like to say X can be anything. I like to say X can be anything. Most of your math teachers will say all real numbers is the solution. You guys don't even know about like an imaginary number, how that can't be a solution. So just remember, all real numbers means like X can be anything, and the things are balanced. Here, we are not going to get either of those situations. We are allowed to have X. And we are allowed to have X equaling negative values. Negative lengths, not necessarily something we want, but X could be a negative value, which would lead to a positive length in a picture. One thing I want you to see, let me just throw in a D here really quickly. If I have X plus 2 equals 2, this is a big mistake students make. They get that, or they just say this disappears and they just are like left with X and they're like, all solutions or no solutions. But remember, X could have the value of 0. That is okay to have. All right, that's homework. Make sure you answer this question. I'll answer this question as well. What do I do outside of school? I hang out with my kids. We got Lola is 8. We got Wally, who is 5. We go to Crux Climbing Center, where we all climb together. I like to also work out. I ride a Peloton. My wife does yoga. We go to concerts. We go to ACL every year. We enjoy our life in Austin. All right, that was the first homework video. I hope you guys appreciate the homework videos, and we will see you out there. Peace.